Hello, fourth graders. This is Mrs. Smith here. Today we're doing Unit 3, Lesson 5, and I have these little bits of tissue here on purpose because I started doing this lesson and I wasn't recording, so this is my second time going through it, but accidents happen and it's all good. So it's on page 115 of your book, and in this lesson we're going to be comparing different methods. Now, we taught you all the methods so you can understand how division actually works. It's not just like some random thing that you have to memorize. It is a logical process that can be represented in several different ways. Now, you're welcome to use whatever method you love the most. And what we're going to do today is we're going to go through a couple together, and then I'm going to challenge you to go ahead and try these on your own. If you need help and you're in my class, you can come to the help session. But we'll then just be correcting these together. And if you're noticing, hey, I'm getting a lot of these right, awesome. Keep using that method. If you're noticing, though, like you'll correct one row, you got some of them wrong, try a different method for the next row, okay? Because you want to be comfortable using all of them. And if you're noticing with one you're making mistakes frequently, maybe stop using that method. Or maybe, just take a break on that method for now, okay? So here we go. Ellie has the place value sections method here, and Jose has the expanded notation method here, and then Wanda did the digit by digit. The reason why you can use any of them is because they'll all lead you to the exact same answer every time, as long as you're doing it correctly, right? So here we have, they've all done 1,194 divided by 5. So Ellie drew her place value sections, right, her hundreds, tens, and ones. She put her 5, the divisor, on the left there, and her dividend, the number that's getting divided, on the inside at the top. Then she asked herself, how many hundreds do I multiply by 5 to get close to but not over 1,194 or 1,100? And she thought, well, 100 multiplied by 5 is 500. 200 multiplied by 5 is 1,000 or 1,000. So then she did that one. She did 200 multiplied by 5, and she got 1,000. Jose did the same thing. He said, oh, how many hundreds do I multiply by 5 to get close to but not over 1,100? And he decided 200. So then he wrote the answer right below 1,000, and they both found the difference. So they both got 194 as the difference. Ellie moved hers into this next place value section, but Jose just left it below. They both asked themselves, how many tens do I multiply by 5 to get close to but not over 194 or 19 tens? They knew that if they did 4 tens multiplied by 5, 40 times 5, that would be 200, which is close, but it's just a little bit too high. So we can't use that. We have to go down. So they'll do 3 tens, 30, multiplied by 5 to get 150. They both subtracted 194 minus 150 and got 44. Ellie moved that into the ones place. Jose just left it there. Then they both asked themselves, how many ones do we multiply by 5 to get close to but not over 44? And they both decided 8 because 8 times 5 is 40. So then they put the 40 there and they subtracted and they found the difference is 4. Then they found that that is the remainder, and their answer is 238, remainder 4. Wanda's method is just more compact and sort of abbreviated, a little bit more succinct, if you will. So rather than writing out all the zeros for like the 1,000 and the 194 and bringing these numbers down, she's kind of just skipping those steps, but like remembering the value of the number. She's not going to write the whole 200 and the whole 30 and the whole 8. She's just going to put the 2 there and leave the 0 spots empty for when she wants to drop in that 30 and then drop in that 8. Same questions though. How many, and she sort of also simplifies the place value language as she does it. So how many, like what do you multiply 5 by to get close to but not over 11? But 5 times 2 and you get 10, right? Then you find the difference, which is the 1, and then she brought down that 9. And then this brings me back to that song that we talked about earlier, where it's like divide, multiply, and subtract, and bring it on down, and bring it on back, right? So then she's doing the the 5 times 3 to get 15. Found the difference was 4. Brought that 4 down. 5 times 8 is 40. Remainder of 4. Okay? Now, we're going to do the same thing, and I've already done it. I'm going to do this method for that one, this method for that one, because I feel like they might be maybe the least familiar for us. I already have the answers written here, because like I said, oh no, I just blew the papers away. Okay. All right. So we'll draw our place value sections method on our whiteboard. Place value sections model, I should say. Put our 5 here, and then our dividend right here, 3,248. Now, how many hundreds would you multiply by 5 to get close to but not over 3,200? Well, 5 times 6 is 30, so 600 would get us 30,000. The difference here, 8, 4, 2. Bring that up to this box over here, 248. How many tens do you multiply by 5 to get close to but not over 24 tens? Not 5, because that would be 25, right? And that's too high, so we'll do 4 tens, which will get us 20 tens or 200, and then we'll have 48. We'll bring that 48 up here, and then we'll ask ourselves, how many ones do we multiply by 5 to get 40, close to but not over 48? If we did 9, then we'll get 45, and we'll subtract, and we'll find the difference is 3. We'll put all that together, 649, remainder 3. And that is what I have over here as well. Okay. Next one, we're going to try Jose's expanded notation method. Okay, so from here, we'll draw our division symbol like that. And we'll write in, I was writing in that problem from his, no, we got to write in the right number. That's going to be important. 5,847, and we're dividing it by 6. Okay. Now, how many hundreds do you multiply by 6 to get close to but not over 5,800? What about, well, 5,800 is a little bit less than 6,000 or 6,000, which would be 10. So let's try 9, which would get us 5,400, over 900 there. And then we'll find the difference, 744. Okay, and no thousands left. Now we ask, how many tens do we multiply by 6 to get close to but not over 44 tens? I know 6 times 7 is 42, so I'll write 70 here. And we'll have 42 tens, or 420. And then we'll have that 7 and that 2 there. And then we'll ask ourselves, okay, how many ones do we multiply by 6 to get close to but not over 27? And then we'll have 4, because that'll get us 24. And then we'll subtract that, and we'll have 3. We'll have 974, just smushing those all together. Remainder 3. And then what do you know? That's what I got the first time too. Okay, so what I'm going to ask you to do is I want you row by row to try, and then I'm going to correct it. Okay, so you'll pause the video, you'll do a row with whatever method you like. If you're getting it right, you'll stay with that method. Or you can move if you want. If you're getting it wrong, try a different method, okay? And you can go back and watch my examples from earlier in the video. But you're practicing building your speed and your fluency and your accuracy with any of these methods. You're welcome to use any of them, but that's what we're doing right now, okay? So go ahead, try this first row here. When you're all done and ready to correct this row, hit play. And then if you get it right, awesome. And if not, well, try something different for the next method, for the next row, okay? So this first row, 5 goes into 8,435, 1,587 times, no remainder. For number 4, 808. For number 5, 1,684, remainder 2. And for number 6, 1,942, remainder 4. How'd it go? How'd you do? If you're missing a bunch of them, go watch one of these examples again, okay? It's important that you're taking note of your own accuracy. All right, now let's turn that page. I want you to try this next row, just this row, on your own. And then when you're ready to correct, hit play. Okay? All right. So here we go. Number 7. 373. Number 8. 486. Remainder 1. Number 9. 314. Number 10. Also 314. Isn't that funny? How'd it go? Remember, you will be probably doing some other assignment, like if my class, probably Think Central, after this. So if you're getting these wrong, watch the examples again. You can also come to the help Zoom. But if you're getting them right, give yourself a little star and know that you did these all by yourself. Very cool. All right, here we go. Final row. Try a different method or stick with the same one. Up to you. All right, number 11. 1,206, remainder 3. Number 12, 1,124, remainder 4. Number 13, 403, remainder 4. And number 14, 1,050, remainder 5. Okay. Hopefully you got all 14 of those right. If you missed a couple, that happens. If you're missing a lot, ask me or your teacher for help, because we're here to help you. Okay? Right. Now let's take a look at this puzzle penguin. And remember, the reason we have puzzle penguin is because he makes, or she, I guess, makes mistakes that kids often make. Okay? And he always has a mistake. So let's see what happened. Dear math students, this is a problem from your math homework. My teacher says my answer is not correct, but I can't figure out what I did wrong. Can you help me find and fix my mistake? So, what I like to do for these is set up the same problem and then try it myself and see what we did differently. Okay, so draw our division symbol. 3,847. I'm writing in 5 here. Okay. I have 3,000 of something. Can you put one of each of them into 5 boxes and not have any empty boxes? No, right? There's going to be 2 empty boxes. So you can't really do that part yet. So we're going to go to 38, right? So 5 times what is 38? Or 5 times how many hundreds is 3,800? Well, let's do 7. And we'll have 35, 3, bring it on down and bring it on back. Get that 4 in there. Okay, 5 times what is 34? 6, 30. Subtract, get 4, and bring it on down and bring it on 7. 5 times 9 is 45. 2. Remainder 2. Now let's look and see. We both got a remainder 2, and we both have 69 here. But he or she said, I guess they said 70. But that really means what they're saying is 5 times 7,000 would be only 3,000. Now think about that for a moment. 10,000 is bigger than 3,000, isn't it? So if you have any amount of like 7,000s, you're gonna have way more than 3,000. Like 1 7,000 is 7,000. 2 7,000s is 14,000. So 5 7,000s would be more like 35,000, right? So they got confused about the place value and they wrote 7 in the thousands place rather than the hundreds place. So let's write that down. Okay. Sorry, bud. You put the 7 in the thousands place. It needed to go in the where? Oops, the hundreds place. And then give him a little smiley face because he's trying his best. Okie dokie artichokes. Thank you for joining me. I'll see you next time. Make sure you're practicing math facts and see you later. Bye-bye.